Hi, Ethan.
Hey, could I test out really quick the sharing function? I do have a little slideshow.
Yeah, I'm just turning that on now.
Fantastic.
There you go.
Let's see, share content. Start broadcast. Fantastic. Can you see the
Yeah.
Yep, we got your title slide there. Okay, so you're host now, Vivek. I'm going to go ahead and drop out. I don't think that will do anything to interfere with the stream, but I will check it after I leave just to make sure that it's still running okay.
Okay, and this will just automatically stop the recording, right?
As soon as you end the
leave
meeting, it'll automatically stop the stream. Yes.
Okay, great. Thank you, Jeremy.
My
Appreciate it.
pleasure. Thank you all.
Thanks. Talk to you later. Hi. Okay, Ethan.
okay, it did end the live stream.
It ended the live stream?
That I got a notification saying that it did.
It should. It shows live on my end.
Oh, all right, maybe I'm mistaken. Maybe that's something else. It's okay.
Okay, it says live on YouTube, so
All
I
right.
assume it's good. Okay. Well,
Fantastic.
okay, great. Thank you for joining, Eric, Ethan. So for folks who are new to this, this is a monthly Bionic Design Forum we have under e-NABLE. And we have speakers from industry and academia give us updates on the latest in the field. And this week, we're really lucky to have Ethan Erickson from Purdue University, student there who'll be talking about prosthetics. So with that, Ethan, let's take it away.
All right, let me go ahead and just share my screen real fast and we'll get started. All right. Yeah, so I'll just give a brief introduction. My name is Ethan Erickson. I'm currently a Purdue student studying mechanical engineering technology. And right now I am the electronics lab supervisor at a student-run design center. It's Bechtel Innovation Design Center. So I work in the electronics lab, and that's been pretty fantastic. But I kind of got into prosthetics when I joined Purdue, and I actually joined the Purdue Prosthetics Club, which actually did have a connection to e-NABLE, and that's how I found out about you guys. But yeah, no, I learned a lot from the Prosthetics Club, and it kind of is what led me to do some of my own research when they decided we should part ways. So basically, when working with the Prosthetics Club, we ran into some significant challenges, primarily having to do with the user input for our device. And so I came up with an idea for a way of a user input, which is similar to how industry currently has a user input. Currently in industry, the way people go about getting electronic prosthetics, and so most of my research is based around electronic prosthetics, primarily because non-electronic prosthetics don't actually have a physical input, whereas electronic prosthetics need some way of taking a physical input and converting it into an electrical signal that can be read. So currently most systems are operate using a single EMG sensor, which is electromyography, which takes the electrical signal in between two muscles and reads a contraction with an analog signal. The way current prosthetics effectively use that is someone needs to go to a doctor, and they'll do tests to determine where the most effective region on, let's say, your affected limb is, and then that's where they would recommend you put the EMG sensor. And so there are several different prosthetics that use these EMG sensors now, even if they are a little bit rudimentary. One of the more popular Hero arms has a single EMG sensor, and it functions with a binary on-off system. So EMG sensors are the most, I would say, prevalent way of receiving user input for electronic prosthetics, and so development of those are definitely going to increase. So I came up with an idea of creating an electronic or an EMG sensor system integrated with a mouse. And so it takes two readings from this EMG mouse, and then it goes into a sleeve that has the EMG electrodes sewn into it. And so this was a project I worked on for a class. It was a really fun process. I learned a ton, and I ended up winning a competition to continue further funding this project. But the real reason I thought a mouse would be a good way of testing our EMG sensors, and really what the mouse is a way of mapping EMG sensors. There are computer mice for limb different individuals that are far better than this. This is specifically for mapping the forearm, like what a doctor would do when you go in. And the reason I decided on a mouse was because there are a lot of different reasons. The first being it's a lot more intuitive and engaging. So I am specifically looking to work with children, especially. And from the research I've gathered, it's not a super fun process going to the doctor. And so essentially these mice would allow for kids to, play a video game while also having their musculature mapped. For now, I'm focusing on upper limb below the elbow amputations or limb different individuals, just because that's the sphere I'm most comfortable in for now. Obviously, this could be extended to a lot of other applications, but the other reason is when it comes to prosthetics, one of the bigger challenges is, especially working with children, is desire of use. I worked with a child who the prosthetics club connected with through e-NABLE, and he was not a fan of the prosthetic we put together. He didn't even really want to try it. It was bulky, and it didn't have a lot of function. And so training someone to use a prosthetic that's uncomfortable is very difficult, especially for children. So what this would allow is it in a sense simulates what a prosthetic would be like, because with a mouse, you have to have precise coordination, and you have to move the mouse around in a two-dimensional sphere. So you're moving your mouse in a horizontal plane, whereas your mouse cursor is moving in a more vertical plane on your screen. And so that eye-hand coordination is essentially very similar to what you would need when you're using a limb that you don't have feeling in, like a prosthetic limb. And then also there are a lot of advantages if this is a fun process and they're able to consistently do this on a regular basis. I think it could be a really great rehabilitation method because a lot of from the research I've done, there is some degeneration and atrophy in the affected limb, and so strengthening the muscles in that limb are crucial for getting consistent and strong, reliable data that you could use to input into a prosthetic hand. And so those are some of the basic reasons why I opted for a mouse design. And this is just kind of our first prototype system. But and so the system allows us to essentially take any game on the internet that you could play on a computer and essentially incorporate that as a part of rehabilitation. So we started with a really basic click accuracy tester, where essentially we looked at our signal input from our EMG sensors, and then we did like a basic click accuracy tester, and that was pretty good, but not super fun. So I ended up opting for a little bit more of a complex system, and we decided to use a game called Geometry Dash, and I'll show a video of how this runs. So this is us testing with the sleeve and the mouse, playing the Geometry Dash game where you have to jump using so basically it's a binary on and off, but you have to tap the screen or click your mouse to essentially control your little figure to go up and down. And so the mouse works by essentially having a input where left and right click are controlled based on where you have the EMG electrodes. So this is an example of what we could get kids to play to increase mobility or accuracy, as well as essentially increase or do some rehabilitation. So that's kind of what we're looking at. And then also another idea I had was for a more advanced system, first-person shooter games, such as, kid-friendly ones, such as Fortnite would be a great one, because that doesn't just require binary input and output. It requires the child to move a mouse around a plane and accurately point at things. And there are a lot of different games that we can use for this application. So some of the challenges we ran into were data input. Our sleeves were not ideal. So most EMG electrodes are wet electrodes, which allows for a more stable contact with the skin. And that's pretty much what most doctors use. And it's a challenge a lot of prosthetics engineers have been facing. There's a lot of research on it. And so my first step is going to be figuring out a way of essentially stabilizing those electrodes. So a few ideas I had were 3D printing a sleeve design out of a flexible resin. And so it's almost like a silicone rubber resin. And so it has some pretty great stretch capabilities, and we'd be able to just 3D print that on a resin printer. And so I've been testing some of the basically resins and seeing what kind of results we could get, and then also modeling out a basic sleeve that we could test out. I'm also working on seeing how our working with different fabrics to see if that will help with a solid connection, because that's pretty much the most important aspect. If you can't have a solid connection with the skin and consistently place them in the same place, your data is going to get skewed. And then there's also the fact that I'm working with some fairly inexpensive EMG sensors that I got off online. They're like $10, not super great. But the exciting thing is I hope to be essentially partnering with another member of e-NABLE, Alberto, who is designing a medical grade EMG sensor with eight channels, which would allow me to get significantly better data and also essentially map more of the forearm, which is so that collaboration is really exciting, and I cannot wait to see what we can do with his system, because he is very smart and a lot better at building electronics than I am. So that's a great, that's kind of a great partnership. So, and then essentially, my goal for the summer is to start doing some trials where I have a child, not necessarily with a disability. It can really be anyone, because essentially I want to see the progression of the use of this device and see if we can determine that based on the electrical data we can collect. Is the signals getting stronger? Is the accuracy getting better? And so that's going to be part of the goal once I've created a more stable sleeve system. And so, yeah, so basically it's going to be running trials, and then eventually I'll be incorporating Alberto's EMG sensor system, which will be a lot better. And then I do need to redesign a more complex mouse. But yeah, so this is just kind of some of my research that I'm doing. And yeah, so I'm really excited about it, and I hope to do more research, especially talking with professionals and people in the medical industry who might know a bit more about the anatomy that I'm working with. So yeah, that's kind of the work I'm doing. I'm not sure how this works, but if anyone has questions, I don't know. But yeah, that's essentially, yeah.
Yeah, absolutely. Yeah, if anyone has questions, please feel free to chime in here. I do have a few questions, Ethan. This is really nice work. Just general curiosity, is this an undergrad or graduate level project? Where do you stand?
This is my personal project. I'm funding it myself. I'm just, it's something I'm passionate about, and so I decided to work on it.
Oh, excellent. Even better. Okay. So yeah, I had heard from Alberto that you're working with him. So in fact, we hope to hear from him next month if you're ready to talk about the integration. That would be really interesting. So have you thought about the integration with a prosthetic device as a possible next step? Any thoughts there?
Yeah, so right now, one of the biggest challenges for prosthetics is like I said before, is ease of use. And so really and this was something I was discussing with Alberto, his goal and my goal is to get a really intuitive sensor array, so that essentially based on the muscular movements in the forearm, they would have almost complete autonomy over each finger based on the EMG signals we get. And so, this is the first step. We need to be able to map those EMG signals. But essentially what we can do is almost a one-to-one transfer for whatever EMG array we have. We can essentially transfer that into a prosthetic limb, and it'll essentially be a really nice transfer, because hopefully the limb different individual will be using this mouse regularly, so it'll essentially be a prosthetic that they can then use that is almost exactly like using the mouse that they had. And so, yeah, so really, I'd like to focus on the mouse because there's a lot of data we need to collect. But yeah, and also, you know, I'd love to work with prosthetics again, but I am a little bit pressed for how much I can take onto my plate. So I will be starting with this, but I'm more than happy to work with anyone else who wanted to try and integrate this with a prosthetic. But yeah, the end goal is to essentially get a one-to-one transfer for prosthetics, so that essentially you would train on the mouse, you'd get the prosthetic, and it would be a seamless integration.
Nice. Yep. We have someone else on the Zoom call, Andy. I don't know. I don't think we met, but if you have any questions, please feel free to ask if you like. Okay, or if not, that's okay too. That's great. I personally don't have any more questions. This is very interesting work. I appreciate your taking the time to talk to us and give us an update.
Of course.
And hopefully next month, we'll see integration with Alberto's hardware, and
Absolutely.
maybe he can do a talk, and you can also attend. That would be great.
Yeah, no, for sure. Yeah, and I'm thrilled to be able to connect with the people in e-NABLE. This is a great organization.
Yep.
It's just been fantastic working with you guys.
Sure is. Great. Thank you for your time. Appreciate it. Good luck. Good luck
All
with
right,
it.
thank you.
Thank you.